The extra credit lecture I went to for physics was the Dr. David Wineland lecture on quantum mechanics. He was the winner of the Physics Nobel Prize in 2012, I believe, or at least recently. His lecture covered a basic explanation of quantum computing and quantum mechanics, explaining Schrodinger's cat and the superposition principle. The Schrodinger's cat is the most of the idea behind quantum computing, in that the state of something can be two things at once. With Schrodinger's cat, the cat was both alive and dead at the same time, and that applies to quantum computing in many ways. He also talked about quantum computing and how even the best scientists can only stabilize a few qubits right now. I've read online that it's 14, but I believe he said that during the lecture, someone asked a question about it, and he says they truly. He said he couldn't really talk about it, which was entertaining because he's a government employee. However, by reading online, it seems like they're not true. The company he was talking about, and he said that they can only stabilize a few, like the range of 5 qubits, and for not longer than 30 seconds at the most. Something I read online on my own is normal bit can only represent 1 or 0. However, a qubit can represent 2 to the number of qubits, states. So if you had 256 qubits, you'd be able to have 2 to 256 states. However, you wouldn't actually even be able to store this number of states because, for instance, your computer might have, at most, like a desktop computer might have 4 terabytes in it, and a terabyte is 2 to the 43rd power, while 256 qubits would have 2 to the 256 power, which is tens of thousands of times greater than the entire storage of the internet. If you took into everything that Google, all the companies in the world had stored, it would still not even come close. Also, something I have found interesting with quantum computing is that though many believe it would be the end of encryption, because it seems like it would be, because of how much more powerful it is, it actually wouldn't be, as the average encryption today is something like 256-bit AES encryption, it's called, and it's used by the majority of websites. When you go to check out, that's what they use to protect your data in between you and the web server. And for those like government employees and that who are trying to protect their own data, they usually encrypt it with 256-bit AES. With quantum computing, the difficulty will be reduced by half, making it, well, not by half, the number of bit difficulty will be reduced by half, so there'll be 128 bits, which is 2 to the 128 is the space of the amount of possibilities in order to break the encryption. And even though it seems like a lot, which it is, it's many magnitudes smaller than 256 bit space. It still would take, even with the entire power of the entire Earth, if you had all the computers working together to solve just someone's 128-bit encoded the desktop, it would still take millions of years in order to get even to the point of having like a 5% success rate, which is all computing encryption really is, because technically, even though it would be astronomically impossible, you could try to crack even 256-bit encryption with your computer today and get it right on the first try. So it's all about breaking encryption, is getting to the point where you have a good probability of actually succeeding. So yeah, that's what I've learned about it, and I found it interesting how it actually wouldn't be that difficult. By the time quantum computing will probably come around, uh, computers will be powerful enough to maybe even use 512-bit encryption, which would then make the encryption the same as 256-bit, which would be, again, way too powerful for even quantum computing to solve, which I found interesting. That's what I learned.